So now example 2 is find the sum of this series. So first of all, we check what type of series is this. So if I divide the second term with the first term, I will get minus 2 over 3. So if I divide the third term with the second term, I will get no, this is not 29, this is actually 20. So I will get minus 2 over 3. Similarly, if I divide minus 40 over 27 by 20 over 9, I will get minus 2 over 3. So I have a common ratio, that is R, which is minus 2 over 3, and A is equal to 5. So it is a geometric series with A equal to 5 and R equal to minus 2 over 3. And since R is equal to minus 2 over 3, that is if R mod, which is equal to 2 over 3, which is less than 1, then the series is convergent. You have seen this in the previous part of the lecture. So the sum of the series is S is equal to A over 1 minus R. A is 5, 1 minus minus 2 over 3, which is plus 2 over 3, and this is equal to 5 over 3, which is equal to 3. So the sum of this geometric series is S is equal to 3. Now the question is the series this given by this is convergent or divergent? No. You can write this series as summation 2 power 2n into 3 over 1 minus n as summation 2 square power n over 3 over 1 minus n as this. You can write it as summation 4 power n over 3 n minus 1, where n is from 1 to infinity, or since this is from the power of this is from n minus 1, so I will separate it as 4 into 4 n minus 1, 3 over n minus 1, where n is from 1 to infinity. Now I can write it as 4 summation 4 over 3 into n minus 1. Now this is my geometric series. This is my geometric series with A is equal to, when I put n equal to 1, I will get A equal to 0, 4 over 3 power 0, which is 1, and R equal to 4 over 3. Since R is 4 over 3, which is greater than 1, so this geometric series multiplied by 4 is divergent. So this series is divergent. Now the next question is write this number, which is a rational number, 3.17, which is equal to 2.317171717 and so on, as a ratio of integers, that is as a fraction. So I will write 2.3171717 up to so on as 2.3 plus 0.017 plus 0.000000017 plus 0.0000017 up to so on. Now this is my 2.3 plus, now I will write it as 17 over 10, 17 over 1000, that is 10 power 3. Now this is 17 over 10 power 1, 2, 3, 4, 5 plus 17 over 10 power 7 up to so on. Now if I consider this series, this is a geometric series in which a is equal to 17 over 10 cube. A is the first term, and the common ratio, that is r, is equal to the second term divided by first term, or the third term divided by second term, which would be equal. That is, if I divide it with this, I will get 1 over 10 square. So 1 over 10 square is the common ratio which is less than 1. Since r mod, which is 1 over 10 square, which is less than 1, so it means this series is convergent. So we know the sum of this series, so I will write the sum of this series as s over 1 minus a, that is 2.317 is now equal to 2.3 plus the sum of the geometric series is now a over 1 minus r. A is now 17 over 10 cube divided by 1 minus r, that is 1 minus 10 square. This is 2.3 plus 17 over 10 cube, and this is 100 minus 1, that is 99 over 10 square, that is 2.3 or 23 over 10 plus this is 17 over 990, and if I add the two terms, two fractions, I'm left with 1147 divided by 493. So now this can be written as a ratio of 2, this ratio of 2 integers. Now the question is, show that the series 1 over n into n plus 1, where n is from 1 to infinity, is convergent. So first I have to write its partial sum, the sum of first n terms, which is 1 over 1 into 1 plus 1 plus 1 over 2 into 2 plus 1 plus 1 over 3 into 3 plus 1 plus up to so on 1 over n into n plus 1. So the first term becomes 1 into 2 plus 2 into 3 plus 3 into 4 plus up to n into n plus 1. So now what will I do is, I will just use partial fraction to write this term. I will just use partial fraction of this term, which is a over n plus b over n plus 1. And if I use partial method of partial fraction, I will get 1 over n minus 1 over n plus 1. So that is my Sn is equal to 1 over 1 minus 1 over 2 for the first term. For the second term, I will get 1 over 2 minus 1 over 3. For the third term, I will get 1 over 3 minus 1 over 4 plus, for the nth term, I will write 1 over n minus 1 over n plus 1. Now this is telescoping term, that is the terms in between are cancelled. This is cancelled with this. 1 over n is cancelled with this. So I'm left with only first and the last term, 1 over n plus 1. Now I have to take the limit of the sequence, which is basically the sum of the infinite series. This is the sum of the infinite series. So 1 minus limit of n approaches to infinity of 1 over n plus 1. Now when n approaches to infinity, this term approaches to 0. So the sum is 1.